Okay, Logic fans, welcome back to our second video on 1.6, and at the end of the previous video, 1.6a, we defined the notion of a corresponding biconditional, right? The corresponding biconditional of a pair of sentences randomly selected. And we're going to use that notion to define this important idea and discuss this concept in this video. So first, let me define it, and then we're going to get into an example, okay? A pair of propositions are materially equivalent if and only if their corresponding biconditional is true. Okay. Now every part of this definition is important, right? You're looking at a pair of propositions. Is this proposition materially equivalent to this proposition? And in order to make that determination, you have to consider the corresponding biconditional of those two propositions. Okay. So let's go ahead and think about an example that I've sort of arranged for us here. Okay. So for the purposes of this example, what I want you to do is I want you to imagine a world in which nothing exists except two things, a blue circle and a red square. So for the purposes of this discussion, to illustrate the concept of material equivalence, we're just going to be thinking about this world in which nothing exists except a blue circle and a red square, okay, and nothing else whatsoever in the whole wide world exists. Okay, so what we're going to do is we're going to assign some propositional constants here, and B is going to be the proposition that you are blue, C is the proposition that you're a circle, R is the proposition that you're red, and S is the proposition that you are a square, okay? Now, I've put up here, for your ease of reference, the definition of material equivalence. Okay, a pair of sentences are materially equivalent, that's the new concept we're learning, if and only if their corresponding biconditional is true. Okay, so first thing I want you to do for this example is I want you to find the corresponding biconditional of B and C. So here's a pair of propositions, B and C. That's two propositions. What's their corresponding biconditional? Then, based on the definition, can you tell me whether that sentence is true or false? Okay. Similarly, do the same thing for the corresponding biconditional of the pair of sentences B and S. Okay. And then tell me whether tell me whether B is materially equivalent to S. Okay. So pause now, give that a shot, and then we'll come back together and work it out. Okay, hopefully you've had a chance to work this out for yourself, but let's go through it together to make sure we're all on the same page, and then I'll discuss generally the idea of material equivalence. Okay, so let's look at the corresponding biconditional of B and C. So the main question that we're considering is whether B is materially equivalent to C. Is it the case that being blue, you are blue, is materially equivalent to the statement, you are a circle, okay? And in this world, that is the case, okay? They're materially equivalent, okay? So the corresponding biconditional of B and C, of these two propositions, is B if and only if C, right? And that just says if you are blue, then you're a circle, and if you're a circle, then you're blue, the left to right and the right to left directions. And notice that with respect to this very narrowly circumscribed world, that's true, right? If you're blue, then you're a circle, and if you're a circle, then you're blue. Okay, so it's a very sort of impoverished, simple, easy world to think about. And that's the notion of material equivalence. Now notice, in our own world, there are lots of blue things, right, that are not circles. Okay, and so in our world, it's not true that B is not materially equivalent to C. Okay, but in this highly sort of restricted universe, it is. Now, it might help, and I'll introduce this now, but we're going to talk about it later in Chapter 2 when we have the notion of logical equivalence at our disposal, okay? But the idea of material equivalence is weaker than logical equivalence. Logical equivalence, if you say that two propositions are logically equivalent, you're saying that they take the same truth value everywhere, okay? So in any world where the one proposition is true, in that same world, the other proposition is also true. And if in some world that proposition is false, then in that world, the other proposition is also false. Okay, they can't help but take the same truth value. But notice the idea of material equivalence is weaker, right? It's true that B is materially equivalent in this world, but it's not like they're logically equivalent. It's not like being blue and being a circle, are the same thing, right? They just happen to coincide because the world is so impoverished. So a really, really nifty example in our own world is the famous example is that of having a heart and having a kidney. All right, so it's true that having a heart and having a kidney are materially equivalent, right? Because everything that has a heart has a kidney, and everything that has a kidney has a heart, right? But you could imagine some world where there are things with hearts that don't have kidneys, or things that have kidneys that don't have hearts, or maybe as evolution unfurls into, billions of years into the future, or on some distant planet, there's some creature with like something we would recognize as a heart and nothing we would recognize as a kidney, okay? And so it's true that having a heart and having a kidney just sort of happen to coincide, but it's not like they're logically equivalent. It's not like anything with a heart must have needs be a kidney. And that's the concept. So, we're working with this weaker concept of material equivalence. Okay. So let's work through this last example here. Let's do the corresponding biconditional of being blue and being a square, or you are blue and you are a square, is you are blue if and only if you are a square. And they are not material equivalent even at this highly impoverished world. Okay, at this highly impoverished world, this very bleak world, it's just not true that if you're blue then you're square, and if you're square then you're blue, right? So these would not be materially equivalent at that world, and they're by no means logically equivalent. And we will discuss the concept of logical equivalence, as I said in Chapter 2, but suffice it to say that if a pair of propositions are logically equivalent, then they're materially equivalent. But a pair of propositions can be materially equivalent and not logically equivalent. Okay, I highly recommend you discuss these concepts with your professor, and absolutely make sure you're doing the practice problems in the text. There's plenty of practice problems there for you to make sure you're really getting these things down. And we'll see you on the next video.